Students, welcome to the lockdown series. So far we have studied about the circular motion and we need to understand about these centripetal and centrifugal force. So I have asked you a question regarding that: is centripetal and centrifugal force are action and reaction pair? So you have answered me that these are the action reaction pair, but one second. We will study about the action reaction in Newton laws. Okay, but uh, whenever a body is subjected to motion, okay, and person pushing the body, and force acting on a body is action, and the force action acted on body 2, this is body 1 and this is body 2, is reaction. We will study briefly in Newton laws, and action reaction pairs are acted upon two different bodies. But here in circular motion there is only one body that is represented here, and the action and reaction force are not applicable here because this is only one body in which centripetal and centrifugal force both are acting. Now the centripetal force is the force that is acted along the center of the circle towards the center. But in the same way, there is another force that you feel when you go in some kind of merry-go-round kind of thing at certain place where you sit, and when it is moved when it is given any angular velocity, it moves in a circle. Then whenever you lift your hand, you will feel a force outwards the center. This force and or the feeling of force become increases when the motion is more rapid. Means whenever there is more circular motion, this feeling of force is more. That means it is not an actual force, it is a feeling, and this feeling is known as pseudo force. So pseudo means misnomer, a false force. But why it is a false force, we will understand it. So basically there are two things that you have understand about the motion. In the previous video we have talked about it, that there is a motion which is always happening with relative to another. Suppose there is an aeroplane that is going in some direction, okay, and you are standing here. So motion about the things always are in reference to one another. So I have told you that reference frame is very important. So if aeroplane drops a bomb or a package, suppose it need to drop it here at your place. Suppose an aeroplane wants to drop a bomb on your head. So what it will do, it will start dropping it from here, and whenever it will reach here, you will see that this will follow this path. Okay, so one observer, that is you, who is observing the package or bomb dropping from the aeroplane, will observe the path of the package as parabolic, or this path. But according to the pilot who is sitting on the aeroplane, according to him, at every point of the aeroplane dropping the package, at every point the package is below the aeroplane. Okay, at every point the package is below the aeroplane. So according to the observer, the path is a straight line. Okay, at every point it will be below the aeroplane, so he will see the package dropping in a straight line like this. The pilot of the aeroplane will see the package dropping in a straight line, but you will see the package dropping in a parabola. So these two representation of the path of motion of the package is different because of two persons who are sitting in two different frames. That is why the motion is always relative. So far we know that the earth is moving around the sun. So anything on earth which you think is a straight line, suppose a car moving on earth, if you think it is a straight line, then the car is actually moving in a spherical earth which is through its center observe a circular path. Now path on earth, that is around the planet, that is around the sun, the earth itself is going in a elliptical path, and the sun across the galaxy is also moving. So these motion whatever we observe are basically relative, and this on account of the difference in the relative motion we observe some kind of force. Now there is one thing that we will learn in the Newton laws. So what is centrifugal force? We will see that centrifugal force is not just a force, it is actually an effect that we feel when an observer is in non-inertial frame feels the force. Okay, so there are two kind of frames you can determine according to our so far observation. One is frames, one is inertial frames, and one is non-inertial frames. So inertial frames, we will talk about. Inertial frames are those frames like earth. So far we know that the earth is revolving around the sun, but so far the earth's diameter and radius is very much bigger than our own perspective. So we are very tiny or very small with respect to the earth. So according to us, the earth is pretty much flat, which it's actually not, but we don't observe any changes in our daily life because of the motion of the earth. Your building, your car, and absolutely stationary. The building in which you live will be there tomorrow, and the river which flows near you will also be there. So far due to motion of the earth there are no changes in our daily life, so we keep earth as an inertial frame. In practicality there are no inertial frames that exist. Everything is in motion, and there are no perfect inertial frames. But any frame or anything that is accelerating with an acceleration, like a train, a car, or anything, that is non-inertial frame. So inertial frames are those in which there are no observed acceleration. Acceleration by the observer in that frame. The observer in that frame. Okay. But when the observer will feel an acceleration subject to a frame, suppose two trains are moving in a direction, in a certain direction. Okay. So according to the same speed and same direction. Okay, so if they are moving the same speed in same direction, the person sitting here will see the person here always opposite to one another. So there are no relative motion with respect to each other in this frame, so they can say that this frame is inertial. But at the moment the one train starts accelerating, okay, the moment this train starts accelerating, now this observer will see this is speeding up and this will go, and now this frame is not inertial. Okay, now this is non-inertial frame. So whenever there is an acceleration subject to any frame, that is non-inertial frame, and whenever there is no acceleration, that is an inertial frame. Now what will happen? So centripetal force and centrifugal force are always opposite to one another. Centripetal force is the real force, okay. This centripetal force is the real force that has measurement and magnitude, and centrifugal force, it is an effective force that you feel, which is actually not there. Okay, this centripetal force is the cause of actual circular motion, and what you feel is an effect that is called centrifugal force. So for any event that is going along a circular motion, two forces acted on a body. One force is toward the center, suppose this is a circle, and this is called centripetal force, and a similar force opposite to that force, opposite to the direction of this force, acted away from the circle. While the cause of this force is centripetal force is known, this might be gravity in case of sun and earth, friction in case of banking of road, tension in case of any string if it is attached to this. This is the cause. But the effect is totally frame dependent, or we will get the insight of this effect, why it is centrifugal, why it is pseudo, we will see in our next class. Okay, this effect, what you feel like force, is not actually force. Okay, this is a false force, this is a pseudo force, and why it is false we will see in our next class. Okay, this is actually due to the inertia of the direction. Okay.